Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know, right? I hope my voice is audible. One second, let me just check. One second. Mhm. Okay, okay. Hi Vaishnavi Gurram, hi, how are you? Hope you are fine and everything is working well, right? One second. Uh, Let me have a look. Uh, yes. I think right now it is working. Yeah. Okay. I just want to know how many of you people are in online so that I will understand. If you are in online, please say a hi so that I will understand. Moreover, you please say like whether the voice is audible or not. Right? Okay. Okay. One second. Okay, bros. I hope my voice is audible to you and everything is working well. Right. So let me start the session. Is that okay? Right? Yes. So okay, today's session is all about limit state of flexure. I hope you know that. In this session, I will teach you about the guidelines or maybe the specifications of IS 456-2000, how to design a RCC beam for flexure. Maybe for 2 hours I will teach. Before I start that session, I just want to say a very big hi to all of you guys who are on the online. Right. Okay. Okay. One second. Right. If you are in online, please say a hi so that I will understand. In the chat box, you please type say hi or anything. Right. Okay. Okay. Before I start the session, right, so I can recommend you to install this Unacademy learning app because so much of free content is happening in this Unacademy learning app. So I can recommend you guys to install this Unacademy learning app, and you can enjoy more free videos from this Unacademy learning app also, right? And if you want to follow me in an academy, you can press this link and you can follow me. When you follow me, there are three advantages are there, brother. The three advantages are: the first advantage is the few upcoming videos will be notified to you, right? That is a good thing, and already done free of cost videos by me that you are able to access. That is the second advantage if you are able to follow me. Third advantage is at the end of each and every class, especially in an academy learning app, for special classes I provide the notes, right? So I provide the PDF notes that also you are able to access for free of cost. All these three are the benefits when you are able to follow me, right? राइट राजकुमार यादव सर हिंदी में एक्सप्लेन कीजिए डियर राजकुमार यादव आई नो आई एम गुड इन इंग्लिश बट आई डोंट नो मुझे उतना हिंदी अच्छी तरह से नहीं आता है सो प्लीज एक्सक्यूज मी फॉर दैट सो आई नो ओनली इंग्लिश सो प्लीज एक्सक्यूज मी अबाउट दैट वैष्णवी गुर्रम हाय वैष्णवी होप यू आर फाइन राइट ओके yes, I think so. Yes, maybe I mean it will be completed by the mid of December, hopefully. By the mid of December, it will be completed. Okay, right. So, okay, right. So before I start the session, so please excuse me for about the language, brother. Okay, I can only teach only in English. Right. One second. Some people will also ask me like, sir, okay. Uh, some people will also ask me like, sir, in the Sun Academy learning app, is there any paid course? Yes, there is a paid course. You are able to use this code VT10. When you are able to use this code VT10, and you can get subscription for the paid course. Definitely you are bound to get 10% discount on all the courses in Unacademy learning app, especially in Unacademy Plus. In Unacademy Plus, you are bound to get 10% discount if you are able to use this code VT10. Hi Ankit Anand, how are you? Hope you are fine, right? And Yes, some people will also ask me, sir, this is my new class. First of all, please introduce yourself so that we will start the remaining thing. Okay, coming to myself, I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, which is PhD also. As my background of education is completely into structural engineering, so I here in Unacademy teach all the structural engineering background subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally into construction materials and management. These six structural subjects only I am going to deal. Some people will also ask us, sir, what is your previous work experience in addition to teaching? Previously, I worked as research scientist or research engineer in University of South Carolina, which is in USA. For this fund, I worked as a research engineer for a funded project. In that funded project, I already worked as a team leader also for that funded project. And previously, I worked as head of the Department of Civil Engineering in an engineering college. This is in India. That means I have both local experience within India and outside of India also. Even till today, being a structural engineer, even till today I am working as an independent structural design consultant. I personally do structural drawings to my clients, and I provide material testing reports to my clients in addition to teaching. This is my brief background of expertise. And coming to teaching experience, till today I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Right? This is my brief background. Some people will also ask, say like, sir, you asked us to install the Unacademy Learning app. Okay, I had installed the Unacademy Learning app. So some people will also ask us how to install, right? Unacademy Learning app. I hope you know. Go to Play Store. So, go to Play Store, and in the Play Store you type this name Unacademy Learning app. When you type this name Unacademy Learning app in Play Store or App Store in I can say smartphone, I can say in iPhone, so you are able to see this type of championship type of trophy. When you are able to install this app, you are clearly able to see definitely a screen which is shown on the right hand side in this way, right? In this screen you keep the target as, here the target as GATE and ESE. When you keep this target as GATE and ESE, and after you keep that target as GATE and ESE, here I hope in this one, in this main button, in this main button you go to Unacademy Plus. Unacademy Plus. When you want to subscribe, when you want to subscribe for a paid course, go to Unacademy Plus. When you had go to Unacademy Plus, there is a thing that is possible called as get subscription. When you had taken subscription, get subscription means in layman language it is nothing but a paid course. This is how you can take a paid course, and they will ask for payment details. You can pay that amount. If you are really an aspirant of GATE and EC, you can do that. Some people say like, sir, we are interested to take the paid course. Okay, for them this is how you can do. Some people will also ask me like, sir, by the time I am taking this subscription, to get discount, is there any code that I can use? Yes, you are able to use this code VT10. When you are able to use this code VT10 directly, definitely brother, 10% discount will directly come on all the courses in Unacademy Learning app. Not only for GATE and ESE course, for any paid course from 6th standard to PG standard, you are able to get 10% discount. When you use this code VT10, definitely I can say it will directly connect between you and me, and it shows your trust on me, definitely, right? Okay, some people will also ask us, sir, how to follow you in Unacademy Learning app. So if you, I hope this is the link that you are able to see. If you press over this link, okay, then definitely you are able to follow me, right? Some people will say like, sir, we are not able to access this link. Okay, in such case, how to follow? Is there any other way? Yes, maybe I can say, maybe I can say like, yes, there is another way is there. Like here, go in this main drop down menu, go to the lectures called as free classes, right? Go to free classes. After you go to free classes, in this drop down menu, after you go to free classes, type my name, Venkata Tilak Uppalapati. When you type my name Venkatila Koppalapati, definitely you are able to access my profile and you can follow me. This is how you can follow me, and I already teach you the advantages when you follow me, right? So this is how you can even follow me also. Some people will also ask us, sir, what are the advantages that I will get if I had taken the paid course, right? So if I had taken the paid subscription, how it is different from free users, right? The first and foremost advantage is instant doubt resolution is possible when you had taken the paid course. In addition to daily live classes, you can directly chat with the educator, and you can ask your doubts directly with the educator, and the educator will resolve all your doubts instantly by the time you had asked the doubts through polls. That is the first advantage. In addition to daily live classes, instant doubt resolution is the first and foremost advantage. Second advantage, in order to succeed in any sort of competitive examination, brothers, any student will require a support of test series. The test series support also we are providing with the help of live tests and quizzes, maybe in terms of mock tests, maybe in terms of grand tests, maybe in terms of subject wise tests, maybe in terms of live quizzes also, right? So while you had written this all these mock tests and quizzes, you will understand at what level you people are when compared to the topmost students of an academy. And if you want to improve your performance, definitely you can improve your performance by attending more number of lectures in that particular subject where you are weak, or by working out more number of problems in the subject where you are lagging the concept. Like that you can improve your performance also, and you can compare your performance also. So finally you can evaluate your performance, and you can make yourself ready for the exam. That is the second advantage. And third advantage is there is no need to plan yourself. We will provide the entire plan if you stick down to the plan. And if you are able to complete all the courses even with test series within the stipulated period of time, whatever the plan that we had given you, then definitely we are pretty much sure, like, you are able to get very good rank, definitely in any sort of competitive examination for civil and for in civil engineering, maybe GATE or maybe ESE or maybe any sort of other competitive examinations. That is the third, I can say, the third advantage. Coming to the fourth advantage, now some days, because of some domestic works or because of some health issues, student may not attend the live classes. In such case, we are providing the same access of the same class in a recorded version, so that the student can access the same recorded version for n number of times within the duration of maybe 1 year or 2 years, depending on the duration of subscription that he has taken. The recorded version may be provided through any sort of comfort of his device, maybe by mobile phone, or maybe by a tab, or maybe by using a PC. So depending on the mode of comfort of the user, he will be given access. This is how we can say. Hi Anand, Ankit Anand, hello, hope you are fine. Hi Prashanti School, hope you are fine, right? And I just want to convey, these are some of the topmost educators that we have. You can have a look at them directly in the app, and the courses will be taught separately in English medium separately, and also in Hindi medium separately. So there won't be any language barrier. If you are a good in Hindi, you can attend Hindi classes. If you are good in English, you can attend English classes. So likewise you can learn the subject without any problem of language barrier, right? Some people will also ask us, sir, till now in GATE and ESE, how many courses you people had launched? As you told us, like, some people will say, like, so you told us, like, when you had taken the subscription, then definitely you will be given access to all the courses that were provided by an academy in that particular branch. Yes. So till now we had started, say, 8 courses. As month by month, as the pool of faculty are going to get increased, so definitely every month we are promising one more new course will get added up. So definitely I can say, when the new courses are getting added up, as you had taken the subscription, you will be given access to all the courses that were running on the Unacademy. On the Unacademy Plus, you will be provided access to all the courses in that particular branch, right? And if you want to follow me, you can use this link, and you can use the code VT10 to, if you want to take the subscription and get and enjoy this 10% discount also, right? So coming to the financial terms, right, everybody will ask us, sir, what is the cost? If it is a 12 months course subscription, if it is a 12 months course, if you want to take, in this case, the cost is 27,225 after 10% discount, brothers. If you want to take 18 months course, in such case the cost is 34,650 after 10% discount. If you are a student of third year or second year, then I can definitely recommend you guys this 24 months course. So in such case, the cost after 10% discount is 39,600. So for any of the course, if you want to enjoy 10% discount, you are bound to use this faculty code BT10, then definitely 10% discount will directly come to you. And if you use this code BT10, then the doors and windows of the Unacademy will be open to you when you had taken the paid course. So there is no need to go to Bombay, there is no need to go to Calcutta, there is no need to go to Delhi. So all the topmost educators are right now available in your single doorstep from your mobile phone, or maybe from your smartphone, or maybe through PC, through online courses. So you can get that by using this by taking the subscription by using this code VT10. Okay. Now I just want to convey one more thing. Like, we already started three new batches. We had already started in this Let's Crack Gate and ESE Civil channel, and I can say, like, you can take the help of those classes also in YouTube, right? Every day my class is happening by 11 a.m., so you can so you can take advantage of all the classes from other faculty also, right? So I just want to convey, I already started a Telegram group also. The name of the Telegram group is Unacademy underscore Civil Engineer Tilak, right? So if you want to come down to this Telegram group, you can use this link which is given below. If you had come down to my channel of Telegram, definitely whatever may be the doubts that you have, you are able to post those doubts, and I can respond to your doubts quickly. If it is in structural subjects, if it is a non-structural subjects, the other faculty who are in that network, they are going to solve your doubts from if it is a non-structural doubt. Okay, so I can recommend, encourage you to subscribe to this channel, Let's Crack Gate and ESC Civil YouTube channel. So definitely you won't miss even a single class of these free courses, definitely. So let's start the session, bros. Isn't it or not? So coming to the session, right? I hope you people are fine, right? So shall we start the session? So in your previous class, we are in the verge of completion of introduction, right? So in limit state method, in your previous class, I need to teach you what the definition of design strength of the material, or design stress of the material. Another name for the design strength or design stress of the material is also called as allowable stress or permissible stress. Another name I can say is called as limiting stress or strength of material. Limiting stress or limiting strength of the material, that is design strength of the material. How we can find out that design strength of the material? If ft is design strength of the material, if small ft is the design strength of the material, for example, it is equal to the actual strength of the material divided by factor of safety. What is called as actual strength of the material? Actual strength of material is nothing but characteristic strength of material divided by, I can say, partial safety factor per material. So these partial safety factors for material I need to consider as per limit state method, right? So how I can consider that partial safety factor for different materials? That is one question. And second question is how to work out that actual strength of the material, which we people call it as the actual strength of the material is also definitely can be called as characteristic strength of the material, which is called as actual strength, actual failure strength of material we can write. Now the question is, sir, how can we define the characteristic strength of the material or actual strength of the material? Is there any definition laboratory wise we can work out, like the load at which the material is failing, the stress at which the material is failing? Generally for concrete, it is the characteristic compressive strength of concrete, FCK. If for steel material, it is the yield strength of the material. Generally, like that wise we can mention the actual strength of the material. But how to define the definition of the characteristic strength of the material in an order wise, or I can say in a regular wise, I can say. Okay, so coming to that, maybe I can say the characteristic strength of the material. This is the definition that was provided in IS 456 2000. This is how the definition was mentioned. So what is characteristic strength of the material, bros? I hope you know the characteristic strength of the material is the strength. I hope clearly it was mentioned. Strength below which not more than 5% of test results are expected to fall. It is the strength. So this is the mean strength at which the probability at which the probability of failure of the material is 50 percentage, right? Here they are saying the strength below which not more than 5 percentage of test results are expected to fail. So not more than 5 percentage of test results are expected to fail means at 5 percentage at 5 percentage probability, I need to find out the strength. The strength at 5 percentage probability, we can call it as F. So I can say if F is the characteristic strength, then as per this definition, F should be less than the mean strength, the mean strength, right? So I hope you can work out. Some people will cry at me like, sir, how to work out the mean strength FM? If you had done 30 observations of if you had done 30 samples, so for 30 samples, 30 different strength values will come, right? So out of those 30 different strength values, can't you work out the average strength, or can't you work out the mean strength, bro? Can you work out the average strength or mean strength? How to work out the average strength or mean strength? Maybe F1, maybe first strength plus second observation strength, third specimen strength, fourth specimen strength. So up to 30 specimen strengths divided by number of specimens are 30. I can do in this way. If I do this one, I will get the mean strength. Okay, but when compared to mean strength, the characteristic strength, I hope, maybe let me show with another color. The characteristic strength here, yes, the characteristic strength here, which is a small f, is less than the mean strength. So I hope this characteristic strength is at a probability of, at what percentage probability? At a probability of 5 percentage. So how I can write that one? As this f is less than fm, I can write this characteristic strength f as mean strength, and this is this mean strength is at a probability of 50 percentage probability of the test results will not fail. So mean strength, and to get 5 percentage probability of working out 5 percentage strength is mean strength minus, I can say, plus probability factor, I can say probability probability factor multiplied by standard deviation, right? So this probability factor k value, which we people call it as normal variate, we people call it as z, some people call it as k, and that value of that z is equal to minus 1.645. so that's the reason why they generally write as f is equal to fm minus k into s, and the value of that k, if you want to work out, the value of the k is 1.65. So that z is minus 1.645. We call it as minus 1.65 times of standard deviation. This is how we can work out, bros. So this is how we can work out the characteristic strength of the material, right? So coming to the safety, some people will also ask us, sir, coming to the safety, what is the check generally we will do in case of limit state method, right? So this is how we can work out the characteristic strength of the material, right? Some people will expect like, sir, if fm is mean strength or average strength for any case, so what is the checks that we can do? Yeah, actually design load should be more than average load, whereas design strength should be less than average strength of material. So maybe average load, maybe I can say called as F me capital FM. I can say this average strength is called as small FM. Design load, maybe I can write as capital F. Design strength I can write as small f. Right. This is how I can mention. These are the safety checks generally we need to use. And coming to the factor of safety, here I already mentioned about na. So here how they mentioned about this characteristic, how they mentioned about this design strength, maybe I can say yeah, capital ft small ft, this small ft, which is nothing but design strength. How we can work out this design strength, which is equal to characteristic strength of the material, right? Can I write that characteristic strength of the material as f characteristic strength of material divided by factor of safety. So what is factor of safety of material? In other words, the factor of safety of the material words synonym, I can write the same word as partial safety factor of material. Both are one and same. Maybe I can say this as partial safety factor of material. Both are one and same. Generally, in limit state method, we call that as partial safety factor for material. In case of working stress method, they call that as factor of safety of material. Both are synonym words, but especially in limit state method, I need to use this terminology called as partial safety factor of material, right? So this is how. And coming to the partial safety factor of material, so these are partial safety factor of material. We call this with a notation called as gamma m, right? And that gamma m for concrete in limit state of collapse is 1.5. In limits for steel in limit state of collapse is 1.15. This you already know. Coming to in limit state of service, in limit state of service, this value, this gamma value, the partial safety factor for metal is 1 for concrete and for steel, right? So I just want to give a small example. Some people will ask me a question, sir, how to work out the design, how to work out the how to work out the characteristic strength of the concrete. So how to work out the how to work out the design strength? Maybe I can say FD is equal to design strength, design stress is equal to characteristic strength of material divided by, I can say, partial safety factor, right? Okay, now if I am able to work out characteristic strength of a material, then for the same material I can work out the design stress. That is a common sense. Now the question is, sir, how to work out this characteristic strength of the metal? This is the question for which we are working out the characteristic compressive strength of concrete. So the compressive strength of standard 15 centimeter cubes are given below. So instead of 30 samples, just for your calculation purpose understanding, if I had taken 30 samples, the calculation is vast. So that's the reason why I had taken 5 observations. And this is the strength of the first cube, strength of second cube, strength of third cube, strength of fourth cube, strength of fifth cube. If I do in this way, now the question is how to work out the characteristic strength of the material. If I had taken the characteristic strength of the material is equal to F is equal to, I can write how to define the characteristic strength of the material, the strength below which not more than 5% of the test results will fall. So in other words, the strength below the strength at which at least 95 percentage of the test results will be above that value indirectly. So in such case, F is equal to, I can write as mean strength minus k times of a standard deviation we can write. And coming to Fm stands for, what is this Fm stands for? This Fm stands for mean strength. How to work out the mean strength or average strength, bro? How to work out the mean strength or average strength of these five samples? Can you work out that mean strength or average strength of those five samples, brother? Yes, I can definitely work out, which is first strength plus second strength plus third strength plus fourth strength plus fifth cube strength divided by 5, right? That is nothing but average strength. So 28 plus 33 plus 30 plus 18 plus 40 divided by 5. This is how you can work out, which will yield you 149 by 5, and it is 29.8 megapascal. This you can do. Now after I work out this mean strength, now the question is, sir, how to work out this value of k, sir? The value of k at a 5 percentage probability, this value, the value of this k at 5 percentage probability, this is minus 1.645. That minus value is already kept here, so I can write 1.645. We can call it as 1.65 also. Okay, that k value is also known to me. And how to find out the standard deviation? How to find out the standard deviation for this observations, man? The standard deviation for this observations I can write as square root of sigma of mean strength minus strength of that first strength of ith sample square by n minus 1. This is how I can work out. And coming to sigma, man's it is summation, right? Everybody knows that it is summation. So okay, coming to this summation, here you people tell me how many coming to this summation sigma here, you tell me here how many observations are there. The observations are 1 2 3 4 5. So I can write the number of observations are I is equal to 1 2 5. And how I can write this one here, man? It is square root of, definitely I can write this as square root of Fm minus Fi. First mean strength is 29.8 minus first strength, it is 28 square. Sigma stands for plus. Fm mean strength 29.8 minus F2 stands for strength of second sample, which is 33 square, right? Plus Fm, I can say mean strength is 29.8 minus this is third sample strength 30, so square. So like that for the other remaining things, for the other remaining things also I need to do. So whole divided by, I can write n minus 1. N is number of observations are 5. I can write 5 minus 1. The answer is 4. So totally this value of this S, the value of this S is 8.03. This is how you can work out. If you want, you can check that one. It's not at all a big deal. So coming to this value of F, which is nothing but characteristic strength. Maybe we can write that characteristic strength directly as, this is the characteristic strength. We can write that characteristic strength as F. F is equal to Fm, which is 29.8 minus 1.65 times of standard deviation. Standard deviation is 8.03. So if you work out the characteristic compressive strength, maybe people usually call it as F6. The characteristic compressive strength, the characteristic strength of concrete for these five observations, it is 16.57 megapascal. 16.57 megapascal. So after you work out this characteristics and characteristic strength divided by partial safety factor. What is the partial safety factor for concrete in limit state of in limit state of collapse? It is 1.15. Maybe you can I rub the screen, bros? Can I rub the screen here? If you please excuse me, can I rub the screen? Right? I worked out the characteristic strength of the metal. If they are expecting you to work out the design stress. How you can work out the design stress? Maybe can I rub the screen? I just want to rub the screen. 1 second. Rubbing the screen. Right. So FD, which is nothing but design stress. If they expect you design stress, they are here in this question, determine the characteristic strength of the concrete. If they expect you design stress or design strength of the material, design strength or design stress of the material is equal to, I can say, characteristic strength divided by factor of safety, or partial safety factor is the correct word for the material. Factor of safety of concrete in limit state of collapse. In limit state, there are two limit states are there. One is in limit state of collapse, and the one is limit state of serviceability. So the factor of safety for concrete, I can say, in limit state of collapse, this value will be 1.5. So which is, in our present answer, we can write as 16.57 megapascal by 1.5. This is how you can get some answer you can get. So generally, if in the design, it just generally in the analysis, if the maximum stress is exceeding this value, then definitely I can say that design is a failure design. Like that we can mention finally. So this is what we can say. So these are the basics about this design. These are the basics about reinforced concrete structures. Now shall we go to the limit state of flexure, bro? Shall we go to that limit state of flexure? Yes. So okay, so I can say directly the first one is this is limit state of flexure. I can say this is for limit state of flexure for singly reinforced sections. Limit state of flexure. So can you define what is limit state? That I already teach you in your previous class. So brother, can you define what is limit state? Limit state is a condition just before collapse. Till that condition, the structure is able to resist loads, all the loads that are acting on the structure, and also provides proper service throughout its life. That is nothing but limit state. So what is limit state of flexure? Limit state of flexure is a condition just before collapse in terms of flexure. Till that condition of limit state of flexure, the structure is able to resist the transverse loads or flexural loads. That condition is nothing but limit state of flexure, right? This I already teach you in your previous classes, right? Now in this limit state of flexure, let us know how to design a beam for flexure through problems. Before I move to problems, I need to teach you 2 to 3 hours of theory, because without theory you cannot succeed in these problems, because it is not just a formula based questions will be asked in this limit state of flexure, bro. Okay, I can say in limit state of flexure, if you refer to the previous questions of GATE, I can say if you understand the concept, then only you are able to derive the formula based on the conditions that were given in the problem. No straight questions will be there. No direct formulas as per IS 456 can be used. We need to derive our own formulas based on the stress block and strain block. If you are able to understand how we are deriving that stress block and strain block, from the stress block and strain block, how we are deriving that moment of resistance, how we are deriving the uh, actual depth of neutral axis, how we are deriving the stress block parameters and strain block parameters, then only you are able to work out the problems, especially in limit state of flexure. So for that one, so please excuse me for that one. I can say I need to teach the theory. If you are able to understand this theory, for the new stress block also, you are able to work out the compression force separately, you are able to work out the tension force separately, you are able to work out actual depth of neutral axis for the new stress block, and you are able to work out moment of resistance also for the new stress block as per the problem given in either gate or maybe ESE. Okay, right. So let me start the theory first. So in limit state of flexure, so in this limit state of flexure, I am using a theorem called Euler-Bernoulli's theorem. Maybe I am using the theorem called as, maybe I can say Euler-Bernoulli's theorem to derive an equation or to derive equations how to design for limit state of flexure. So generally this for this limit state of flexure I need to take a beam, right? I had taken a beam, the width of the beam is having a width b and the total depth of the beam is having a total depth d. So maybe I can say b is width of beam. I can say capital D stands for, I can say from here to here, it is capital D stands for the overall depth of the beam. Overall depth of beam. What is here? Small d stands for, small d stands for from here to here, small d stands for effective depth of the beam. Effective depth of the beam. So the small, how you can define this effective depth of the beam? It is the distance from the compression flange of the, from the extreme compression layer of the beam to the center of gravity of this. What are these? This steel is nothing but, this is nothing but area of tension steel. This is compression zone and this is tension zone. I had taken a beam, maybe I had taken a beam here. Okay, so if I apply transverse loads in this way, the tension is there on the, on this bottom side. Generally if I take, maybe the neutral axis is somewhere here, maybe definitely you can write like this is compression side and this is tension side. So as the concrete is weak in tension, definitely I need to provide reinforcement in tension zone, right? So that's the reason why the area of tension steel is generally provided in on tension side in this way. This is main, this is the tension steel which is provided on tension side. In this way how the tension steel is provided, right? So this is how the tension steel is provided. This is the tension steel. This is the area of steel in tension. So AST stands for, maybe I can write here clearly, AST, area of tension steel. Here there are three bars. Let us suppose here in this one, maybe I hope clearly you are able to see. Here there are three bars are there, maybe one, 2 and 3. There are three bars are there, and there are three bars here. Directly area of tension steel here we can write as 3 times of pi by 4 into, what is the cross sectional area of each and every bar? Pi by 4 times of diameter square. So like that we can mention, of course. So that area of the steel, for this example I can say as 3 into pi by 4 into d square. That's a different thing, right? Now in this Euler-Bernoulli's theorem, okay, I hope as per Euler-Bernoulli's theorem, there are certain assumptions are there. I want to talk about the assumptions of this Euler-Bernoulli's theorem. Assumptions. What is the first and foremost assumption in this Euler-Bernoulli's theorem? In this Euler-Bernoulli's theorem, the first and foremost assumption is there is no distortion in the in the shape of the cross section after bending also. So I can say no distortion in the shape of cross section. So as there is no distortion in the shape of the cross section, strain, I hope you can say this is the strain distribution. Strain distribution is linear with the, there is no distortion in the shape of the cross section. Strain distribution is linear, I can say. Strain distribution is linear with zero strain distribution at the neutral axis and maximum at the extreme compression fire maximum strain. This is strain distribution. So I hope maximum strains are possible at the ends. Okay, and I can say this is the strain in tension steel. I can say this is strain in tension steel. We can say epsilon st, and this is strain in tension steel epsilon st. I can say the maximum strain is possible at extreme compression fiber, and at that extreme compression fiber the strain is limited to 0.0035. I will mention the reason also why the maximum strain in concrete is limited, especially in compression is limited as 0.0035. This is the strain distribution. This is how the strain distribution is possible, right? So I can say this. Some people are saying, "Sir, you are using this Bernoulli's theorem. This Bernoulli's theorem is valid. This Bernoulli's theorem is valid even for composite members also, and this Bernoulli's theorem is valid up to failure, up to the failure. When the Bernoulli's theorem is valid up to failure, I can say this Bernoulli's theorem can also be applied even for limit state of collapse also, na. So just before limit state of collapse, the structure is not going to fail. If the structure is completely failing, I can say the structure has attained limit state of collapse. Definitely I can say that, right? Isn't it or not? So I can say like maybe I can say here, if you see uh, here directly I can say, maybe if I rub the screen here, maybe I can say here, I just want to rub the screen here. Okay, erase all the ink here. This is a strain in tension steel, na. So sorry, this is wrong. This is the strain in tension steel, epsilon st. Okay, epsilon st. What is this epsilon st? This is strain in tension steel, right? I just want to say like here Bernoulli's assumption is valid. Bernoulli's theorem, Euler Bernoulli's assumption, Euler Bernoulli's assumption is valid even for composite sections also, valid for composite members also. So as this is applicable even for composite members, that's the reason why we are using this Bernoulli's theorem, Euler's Bernoulli's theorem. I can say even for RCC structure, because RCC structure composed of two metals. One is concrete and second one is steel. So it is actually a composite structure. I can say it's a composite member. I can say so. As the Bernoulli's assumption is valid for composite members also, I can say so. This I can say this is valid up to failure. So it is, and it is valid up to failure. So as it is valid up to failure, I can say this Euler Bernoulli's theorem, I can say, is applicable even in limit state. So therefore it can be used even in limit state method also, limit state method also, right? So I hope you had seen this one. I just need to mention why I am considering the maximum strain in concrete at extreme compression fiber as 0.002. What is this strain which is 0.002? I need to mention these two, how I got these ones, and everybody knows why the strain is linear in fashion, right? And I just want to convey in, especially in this limit state of method, or even in Euler Bernoulli's theorem, I can say like concrete is good in compression. Yes, concrete is weak in tension. The concrete which is in tension zone will not resist any sort of stresses, right? So I can say that. So, and one more thing here. So concrete is weak in tension. So concrete in tension zone will not resist any sort of tensile stresses. concrete in tension zone. So that's the reason why I can say so. The concrete in tension zone uh, will not resist any tensile stresses. So in tension zone, who is there to resist the tensile stresses? The tension steel is only there to resist the tensile stress. So in tension zone, tension steel only resists the tension. This is the tensile stresses indirectly. Okay, now the question is, some people will also ask me, sir, really the concrete doesn't have, not even the concrete can resist even very small tensile stresses also. Concrete can resist very small tensile stresses, which is very negligible. If you are very particular, and if you are interested to learn about the value of maximum value of tensile stress the concrete can resist in tension, if you want to know, you need to know about modulus of rupture, right? Shubham, right. Sir, when your classes start on Unacademy Plus eagerly waiting. Dear brother, when the concerned persons or Unacademy team say, then I will let you know. Okay. So till now there is no information about me when I can start about that. So when there is some information is there, definitely I will mention that to you. Okay. Right. Shubham, right. Okay. Now the question is, sir, now the question is, can I rub the screen here? Some people will also ask us, sir, okay, we understood this one. Now the question is, sir, what is the maximum value of tensile stress resisted by concrete? Maximum value of tensile stress resisted by concrete. Generally, it cannot be exactly zero. There is some very lesser value, the tensile stress resisted by concrete, and that is nothing but which is called as modulus of rupture. Modulus of rupture, which people call it as FCR. How we can work out that FCR? If you had seen the code of practice IS 456, this modulus of rupture FCR is taken as zero point 0.7 times of root FCK, and when compared to FCK, zero point 0.7 times of root FCK is very less, right? If you take maybe 20, zero point 0.7 times of root FCK is almost 2 megapascal, right? So I can say this is very less, say very less when compared to compressive strength, right? So that's the reason why. So based on this reason, the tensile strength of concrete is neglected and it is kept as zero, right? So I can say, so due to this, so because of which the tensile strength of concrete is neglected and is treated as zero. Zero. This is how we can say. Some people will also ask me, sir, how to work out this modulus of rupture in laboratory testing, sir? How to work out? This is an empirical rule. How to evaluate the modulus of rupture? If I want to work out the actual value of modulus of rupture, the flexural tensile strength of concrete. So, which is how to work out the flexural tensile strength of concrete? I hope you know. You take a prism of dimension 150 by 150 by 750 dimension and apply a bending test. So FCR, here FCR is tensile strength of concrete in bending or flexure. In bending or flexure. Now the question is how to calculate that FCR. How we can calculate that FCR, man? I can say FCR, the bending tensile strength of concrete. FCR is calculated by, I hope you know, 2 point loads on 2 point load on beam or prism. This, I hope, if you are expecting me to show how we can work out that one, I hope you might had observed. Can I rub the screen here? Some people will also ask us, sir, how this FCR is worked out in laboratory. Maybe I will take a specimen of dimension 150 by 150 by 150 by 150 by 750, and we if we apply over this is the simple support and this is the simple support. Here we apply two transverse loads. Maybe this is how we will apply two transverse loads. So on this one, at what load, this is plain cement concrete. This plain cement concrete is subjected with two transverse loads. The load at which this plain cement concrete block is failing, we can work out, and FCR we can work out as moment of resistance M by I into Y max. So based on this formula, because it is a plain cement concrete, na, when it is a plain cement concrete, it is a single material is there. It is not a composite material. When it is a single material, I am free to use flexure formula directly to evaluate stresses, to evaluate bending stress and to evaluate bending strength also. So to evaluate that bending strength, FCR is equal to M if it is P, and if this is P, and this maybe this is A, this M is equal to P into A by I maybe we can work out this as this is 150. Maybe I hope you know uh, this is 150. This is also 150. About this axis only bending is happening. So I can say, sir, 150 by BD cube by 12 into Y max. The maximum fiber distance is 150 by 2, right? And this A distance, this A distance is, I hope you can see, 150 into 4. 150 into 4, it is 600, na? So 600 divided 150 into 4. So 150 into 4, 600. 600 by 3. So this distance is 200 millimeter. So this A value will be 200 millimeter. P is the transverse load at which this flexural element is failing. This P can be recorded directly from flexural testing machine. So P is known, A is known. So I can work out this FCR. This is how I can work out this flexural tensile strength of concrete. Definitely, right? So okay, I hope you know how to work out that FCR, but that value is very less when compared to compressive strength of concrete. So that is approximated as 0, right? So that's the reason why we are saying concrete is weak in tension and it is not taking any sort of tensile stresses. Okay, now the question is, sir, okay, sir, here you told us like how the strain, how the stress block is in this way. You need to answer why the distribution of stress block is in this way. Some part is just like that of a rectangle portion, some part is just like that of a parabolic portion. You need to mention answer for that one, and you need to answer even why the maximum strain in concrete in compression fiber is taken as 0.0035, and just between the rectangular variation and the parabolic variation here at this point, why the strain in concrete is taken as 0.002. So there are four questions you need to answer these things. Yes, brother, I will definitely accept. Yes, I need to answer for four things. So to answer for those four things, shall I rub the screen? I need to answer why this, why the variation of the stress block is in this way, and I need to answer also why the maximum strain, why the maximum stress, why the maximum stress in concrete in compression fiber is limited as 0.45 FCK. Why this? 1, 2, 3, 4. Maybe why it is, why the variation is just like that of a rectangle here, right? Maybe I can say why the variation, 1 second, why the variation here is just like that of a rectangle here in stress block, why the variation here is just like that of a parabolic here. So I need to mention the reason for what depth this rectangular variation is possible, for what depth this parabolic stress distribution is possible. So I need to answer 6 to 7 questions first, right? So let me answer one by one, bit by bit. Is that okay? Right, so let me answer everything bit by bit. So before I starting answer the reasons, okay, let me take a pail of water. Okay, right. Let me rub the screen here. Let me erase all ink on this slide. Okay, now let me take the felt tip. I just want to show first of all why the shape of this stress distribution is just like this. It is why the stress distribution is like this. I hope you can say this is compression and this is tension, right? This is the concrete which is under compression. This is the concrete under tension. So when the concrete is under compression, how the stress block will be, right? I just want to write. So what is the original stress strain curve of concrete in compression? If you take the original stress strain curve of concrete in compression, this is how this is stress, this is strain. I hope you can take a concrete cube, and if over the concrete cube, if you are testing for axial compression, this is how the shape of, this is how, maybe I can say, this is how the shape of stress strain curve is possible. This is stress and this is strain, and it will come as a parabolic way in this way, definitely. This is how the stress strain curve is possible, and somewhere it will fail here. Okay, I just want to say this is origin O, and this point is called as A, and this point is called as A, this point is called as B. Some people will also ask us, sir, what is this point A, sir? What is this point B, sir? How we can define that one? This is the point A at which you are able to observe on the testing machine on cube the first crack. So it is the stress corresponding this to this point A, where there is a possibility of first crack in concrete cube. So I can say what is the name of that point. The point at which first crack is happening is called as stress at first crack. Can I write that one? So this is the stress. Maybe I can write. Let me change the color. Okay, this is the stress at first crack. So when a single crack has got happened in concrete, by the time we can say like the concrete has got failed. So indirectly it is nothing but the actual failure strength of concrete. So indirectly I can call this, definitely this is strength. This strength is called as definitely FCK, no doubt. Okay. Now, so but even after first crack also, there is a little increase in strength, maybe very little increase in strength, maybe 5%, maybe 2% or something like that. A little increase in strength is there. So I can say at this point B, this at this point B, I can say it's a complete failure. I can say, maybe I can say from A to B, it is still increasing. That increment is little, definitely. I can say B is the point where it is completely failing. Completely failing. Okay, now this is the actual, what we can write, this is the actual stress strain of concrete in which mode, man? In compression, in in compression, right? Shall I need to write that in compression? I had written that. Now, after from A to B, the increment in strength is very, very little. Of course, the increment in strength is very, very little from A to B. Maybe the percentage is 1, 2% or 3%. I just want to mention generally for any sort of concrete, even for high strength concrete or for low strength concrete, generally this value of this FCK only will get increased. Okay. but the strain at which first crack is happening is always constant. What is the strain at which first crack is happening? The strain at which the first crack is happening in case of concrete or axial compression is 0.002, which we people call it as 0.2 percentage of strain indirectly. So generally, if you take any concrete, any traditional concrete, I am not talking about special concretes. If you take any traditional concrete of any strength, maybe M300, M400, M500, M600, M1000 also, if it is made by traditional concrete without addition of any polymers, without addition of any other things, generally if it is a traditional concrete, even if it is M20 or M30 and whatever that may be, I just want to say the first crack in concrete in axial compression is initiated at a strain of, practically it is initiated at a strain of 0.002, right? That is the constant value for any grade of concrete if you can take. And at what strain the complete failure in concrete will takes place in axial compression? At a strain of this is also a standard one. This what is that strain? That is nothing but the maximum strain, the limit, the ultimate strain of concrete at failure. This is nothing but ultimate strain of concrete at failure. What is the ultimate strain of concrete at failure? This is 0.35 percentage strain. So in other words, how I can write this as 0.35 percentage strain? Can I write it as 0.0035, right? Yes. So I hope you can see this point. Maybe let me write with the help of another color. Maybe this point 0.035 is the ultimate strain in concrete. Ultimate in sense maximum. Ultimate strain for in concrete at complete failure. What is this point not to? It is the strain in concrete at the time of first crack. At the time of first crack means at the time of yielding in indirectly, right? So what is that strain at point not to? So point not to strain is the yield strain in concrete. What is yield strain in concrete? It is the strain in concrete at the time of first crack. So, or in other words, it is strain in concrete at a time of first crack. Right. 1 second. Maybe I can say strain in concrete at initial or first crack. That's how I can say. Right. So I hope you understood. Okay. Now you understood. Okay. What is that point not to and point not to? This is the actual stress strain curve. But I just want to convey one thing. This is the actual stress strain curve. There is no doubt at all. But from point A to point 5, the increase in strength is very, very less. So from A to B, instead of going it as a curved fashion in this way, in the idealized stress strain curve, how we had considered the same stress strain curve as an idea. This is the actual stress strain curve. How I can consider the revised stress strain curve, right? And I can say what is this zone? AB zone is nothing but AB zone is nothing but crack widening zone. Can I write that one? Crack widening zone. And I hope you can say from point O to A. How you can mention about this point OA? This point OA, this shape is in non-linear shape and it is non-linear elastic zone. OA zone is non-linear elastic zone. OA non-linear elastic zone. Some people will also ask us, sir, here why there is no straight line is coming, why it is a curved fashion? Dear brother, this material of concrete, plain cement concrete, is a brittle material. For plain cement concrete of for brittle metals, generally from your strength of metals background, maybe your SM teacher might have already teach you, like for brittle materials, for brittle materials, proportionality limit, proportionality limit coincides with origin in at stress strain curve. Proportionality limit coincides with origin at in stress strain curve. I can't say in stress strain curve. So I can say at point O only this proportionality limit has got coincide. So from O to proportionality limit it will be straight line. Both has got coincided at this origin. So there won't be a straight line portion. Right. So here after straight line portion till elastic zone is there. But that elastic zone is a non-linear elastic zone from O to A. O to A is a non-linear elastic zone. So that's the reason why for brittle materials I can say there is no straight line stress strain curve is not possible. Only curved stress strain curve is only possible in elastic zone, which that zone we call it as non-linear elastic zone. We can say, right? Nagarjuna, sir, is there? You will complete entire structural part in ESE point of view. Yes, brother, I can complete almost all the things, brother. Definitely, Nagarjuna. Definitely, but not entire subject. I can say maybe like 30 percentage 40 percentage of the syllabus I can complete in depth. Okay, right, this is what I can say from my side. Is that okay, dear Nagarjuna? I hope I answered you, right? If I teach everything 100 percentage in detail in for free classes, so nobody will purchase. From common sense or from point of view also you can understand. I won't lie anything. But maybe 30 percentage, definitely 30 to 40 percentage for sure in detail, in depth, I will teach with reason, even in ESC point of view, in GATE point of view, everything. Everything I will tackle. Right? Yes. Okay. I hope you are understanding the reasons also, right? Yes. Okay. Now, this is the actual stress strain curve. But now the question is, sir, why this curve has got this shape, sir? And why I am getting this 0.45 of secant? Let me come down to that one. Okay. Right. So maybe can I rub the screen, dear Nagarjuna and Shubham Roy or any other person who are on the online? This is the actual, please understand, this is the actual stress strain curve. But in order to make our analysis simplified, I need to idealize, I need to simplify this stress strain curve, isn't it or not? So how I can simplify the stress strain curve of concrete and compression? I want to do that, isn't it or not? Right? I just want to rub the screen here. Yes, let me rub the screen. I just want to say like here. So this is the revised stress strain curve. I just want to convey in the revised stress strain curve. This is the stress. This is the strain. I just want to say this is revised stress strain curve. Not given by me. This is given by IS 456 with reason I will mention. So this is revised stress strain curve as per IS 456. I can say 2000. So I hope you had already seen like this is how the actual stress strain curve is. Maybe from O to A it is from O to A it is a curve, sir. Okay. From A to B it has got increased in a straight line a bit from O to A. But from A to B it has got the increment in strength is very less. So that's the reason why that increment in strength is very less. Na? So instead of that as a strain hardening zone, maybe the code has the code not maybe the code has taken that as from A to B as a flat zone, because from A to B in original stress strain curve the increment in strength is very less, right? So as the in crack widening zone, the crack widening zone, the stress strain curve is made as flat, right? So in crack, so maybe this is O A, this is AB. So what is the strain at this point A? Point not 2. What is the strain at this point B? Point not 35. This I already mentioned with reason already, right? So this is how the revised stress strain curve. This I can say the what is the stress at the time at point A. It is nothing but stress at the first crack. What is the stress at the first crack, which people call it as FCK, stress at first crack, which we call it as failure stress. Okay, this is the revised stress strain curve as per IS 456. But shall I take this as the final one? No. I hope I can say this is the stress strain curve acting on this is the stress strain curve for cube. I can say revised stress strain curve for cube. I hope you can see when you had taken a cube and a real structural member. The shape of the cube is The size of the cube is 1.5 by 1.5. The size of the cube is 150 millimeter by 150 millimeter by 150 millimeter. In real structures, whether all the structure sizes are 150 millimeter by 150 millimeter by 150 millimeter, is the shape of the structure is also just like the cube? No, that is, this is the stress strain curve for cube. I want to draw the stress strain for curve for concrete for structural members, in structural members. So how I can take this? This is FCK is the failure strength for concrete for cube. I just want to write. So the strength of the concrete, I just want to write a note like, note is the strength of concrete in a structural member will be less than the strength of concrete of a cube, right? Right. The strength of concrete in a structural member will be 33 percentage less, will be effect due to size and slenderness effect. In realistic structure, the cube is having a dimension of 150 by 150 by 150. But our, if you take a real beam, the shape of the cross section of the real beam may be 200 millimeter by 500 millimeter depth, and that it is also having very good length also. In such case, it has got size change is there, and there is a concept of slenderness effect is also there. So because of this one, the strength of concrete in structural member will be definitely less. And how much percentage it will be less? 33 percentage less. So if this is FCK divided by, I can take the partial safety factor for shape and size effect. So maybe I can take, this is how the, maybe I can say this is how this curve will come into picture. So what is this curve is called? I can say clearly, this is the curve for structural member. So okay, for structural member, what is the failure stress for structural member? That failure stress will be less than FCK. And what is that value? Maybe I can say this value is FCK by factor of safety for shape and size effect. The factor of safety for shape and size effect is 1.5. So which is nothing but 0. I can say, maybe I can say this is 0.667 FCK. This point is 0.667 FCK. When compared to FCK, you see, when compared to FCK, how much percentage drop in strength for the structural member? For structural member, the strength is 0.667 FCK, or 0.67 FCK if you take. When compared to FCK, what is the percentage drop in strength for structural member? The structural member has got dropped a strength of 33 percentage. Indirectly both are one and same. How you got that one? By taking the effect of shape and size factor. Maybe I can say here, 1 second, this 1.5, what is this 1.5 in sense? I can say shape and size factor, isn't it or not? Now can I use this as the actual design stress strain curve? Because in the stress block I need to use design stress strain curve. This is the structural member. Okay, this is the stress strain curve for structural member, but I need to use the design stress strain curve. This is maybe the actual stress strain curve for structural member, maybe actual stress strain curve. I can say instead of actual stress strain curve, this is the ideal stress strain curve for structural member. But I want the design stress strain curve. How you will get the design stress strain curve, brother? Design stress strain curve is equal to actual stress strain curve, or maybe this structural member stress strain curve divided by factor of safety of the material. What is the factor of safety for the material of concrete? So this is for structural member. I just want to write another curve, right? Maybe I can show with another color. Definitely yes, I am going for another color here. I am showing that in this. This is how. What is this blue one? This blue one is called a design stress strain curve. Design stress strain curve of concrete. So how you will get the design stress strain curve of concrete? The idealized stress strain curve for structural member of concrete divided by factor of safety of concrete. Already the strength is zero. Already the strength for structural member is 0.667 FCK. After I do this, how I can get the design strength of concrete? Actual strength of structural member divided by factor of safety for concrete. So what is the factor of safety for concrete, brother? The factor of safety for concrete in limit state of flexure is already 1.5. So I can write directly here. Maybe I can write here as, if you please excuse me, this value is definitely, yes, maybe I can write it here. So design compressive strength of concrete is equal to this 0.67 FCK divided by partial safety factor of concrete. How I can write that one? We can write this one clearly as 0.67 FCK divided by factor of safety for concrete in limit state of flexure, which is 1.5. So I can say what will be the final answer, bro? The final answer must and should be 0.45 FCK, right? So that's the reason why I can say here maybe this, if you please excuse me, uh, I can take this is strength here, this strength here, it is 0.45 of ck. So what is this curve is called? This is design stress strain curve. Now you can see this is the stress strain curve here. At this zero means what? Mean at this point the strain is zero. In this is the compression zone. In this compression zone, maximum strain is possible at the extreme compression layer. Minimum strain or zero strain is possible here. So the same stress block, I can reverse it. I can keep this. If I can keep the same thing here. There is zero strain, so this point of O can come here. Maximum strain is possible at the extreme compression fiber here. So here I can say maximum stress here it is possible, and the maximum stress is possible is same stress strain curve. Try to what you can say, try to keep here in this way. Maybe let me write here. Let me shift, let me clear this one second. Ink. Maybe erase all the ink. So this is how I got this final stress block, right? This is stress strain curve, and this is the final, one second, and this is how you got the final design stress strain curve for concrete, right? This is how you got, and that value here it is maybe 0.45 FCK. This is O. I can say this is A, this is B. This is how it is, right? Now after this, I can say this is this is point O, this is point A, and this is point B. At point A, you tell me what is the strain at this point A. AB is nothing but crack widening zone. Na? So this from A to B, this variation of stress is just like that of a rectangular variation, right? And the strain here it is point not not two. So at point A, this is point not not two. So here and from this layer, so from this above these layers, I can say above these layers from here to here, the layers here in this concrete has got started, will get start cracked when the strain in concrete has reached here a strain of 0.0035, right? So I can say this is 0.002, this is 0.0035. And you got why I got this answer of 0.45 of ck. This 0.45 of ck is the design compressive strength of concrete. Design compressive strength of concrete, right? So that's the reason why we got it as 0.45 FCK. And why we got this 0.0035, this is answered. Why we got the strain at the jet when there is a change between rectangular variation and parabolic variation as 0.0025, this is yield strain. This is ultimate strain, right? So I just need to I just want to define, I just need to mention here epsilon st I need to mention, right? I had mentioned even the shapes of this. Now coming to this, some people will also ask us, sir, okay, can you tell me what is the overall factor of safety used for concrete? What is the overall factor of safety used for concrete? I can say out of factor of safety, 1.5 is the factor of safety for shape and slenderness effect. 1.5 factor for shape and slenderness effect. Again, 1.5 is factor for, I can say, partial safety factor of concrete. I can say for partial safety factor of concrete. So totally, what is the overall factor of safety used for concrete? Overall factor of safety is one factor of safety for shape and size effect is 1.5. Another of factor of safety is 1.5. So totally, I can say 1.5 into 1.5, which is 2.25. If you write 1 divided by 2.25, you will end up with definitely 0.446 fck, which is 0.45 fck. So I can say the overall factor of safety used for concrete in flexure, in limit state of flexure. Overall factor of safety used for concrete in limit state of flexure. It is not just 1.5, it is 2.25. 1.5 is the answer. It is when it is partial safety factor of concrete. When I say overall factor of safety, overall safety factor for concrete in limit state of flexure is 2.25 in compression, right? This is the answer, right? Yes. So it is not just 1.5, dear Shebin Sailuddin. I hope you are understanding where you are making a mistake. There is a lot of difference between partial safety factor for concrete and overall factor of safety of concrete in limit state of flexure in compression. 1.5 is for shape and size effect safety factor, factor of safety for shape and size effect. Another 1.5 is the partial safety factor for concrete in limit state of compression. If I want to work out overall factor of safety, it is 1.5 into 1.5. Just 1.5 is not correct. The finally the answer is 2.25. Is it okay, dear Shaybin Sailuddin, where you are making a mistake, right? Okay, right, right. So shall I, some people right now will ask us, sir, you mentioned about what is the limit, what is the maximum strain in concrete, okay, but you didn't mention what is the maximum strain in steel at a time of failure, right? So I just want to convey right here. So can I rub the screen here? Maybe I just want to rub the screen here, erase all the ink. Some people will question me like, sir, strain for failure strain for concrete is given, but failure strain for steel is not given by you. Why you had not given failure strain for steel? So why the value for failure strain for steel is not given? I just want to say one thing. Just before the failure of concrete, failure of just before the failure of steel, failure of concrete generally happens. So that's the reason why I had given only the failure strains of concrete only. I just want to write strain at failure for steel is not given. What is the reason? As the concrete fails much earlier to the failure of steel, right? So that's the reason why I didn't give till now. Okay, some people will say, sir, you had shown only the idealized stress strain curve or design stress strain curve for concrete only, this much only, but you didn't show the design stress strain curve for steel. So can you show the design stress strain curve for steel? Yes, definitely. Why not? I can show the design stress strain curve for steel also, right? Yes, I hope. Yes. 1 second before this one. Okay, right. Let me show here design stress strain curve for steel. Maybe I just want to write stress strain curve for steel. Stress strain curve for steel. See, the stress strain curve, the stress strain curve for steel, for mild steel stress strain curve will be different, and stress strain curve for HYST steel is different, right? I just want to show the stress strain curve for, I just want to show for mild steel first. So how you can show the stress strain curve for mild steel? This is how I can show. This is a stress and this is a strain, and you can show this is just like a straight line, clearly we can show, and there is an upper yield and lower yield, and after that one maybe you can show an yield plateau. I can, you can show a plastic zone, and after that one strain hardening zone you can show in this way, right? I just want to say here this point is nothing but proportionality limit. I can say this point is nothing but yield. This point is nothing but yield stress. I can clearly say this is yield stress. I can say Fy, right? At yield stress, generally for mild steel at yield stress, what is the strain that is possible? The strain that is possible at yield stress for mild steel is the same point, not 2, so which is called as 0.2 percentage of strain. This is actually called as this is original stress strain curve, we can say. Okay, original stress strain curve for mild steel. But if you see in this original stress strain curve, maybe this point is A, I can say this point is B. This, if I take, this is the elastic zone, this is plastic zone, and maybe this is strain hardening zone. If I take all these zones to totally in together, then analyzing this taking the tensile strength is difficult. So this curve has got idealized, this curve has got simplified to show the idealized stress strain curve. So what is that idealized stress strain curve? I am idealizing this complex stress strain curve into a simple stress strain curve. How I can show that simple stress strain curve, bro? Maybe I can show here, maybe here itself. This is how I can show the stress strain curve. So from O to A, this is a straight line, and from A to B, and from this is from B to C. This is how I can show. A, this is B point is I can say yield stress, and C point is the end of I can say the plastic zone. I am showing only these three parameters. This is nothing but idealized stress strain curve clearly, and I can clearly show the stress at this point B is nothing but yield stress. We can call it as F5, right? And this point A is nothing but proportionality limit. Definitely at point B, what is the strain? At point B, the strain is point not 2, which is 0.2 percentage of strain, right? And at C also the stress is Fi, I can say, because BC is there. What is BC? BC is a plastic zone where the stress is constant, only straining is possible, right? This is the idealized stress strain curve, but always I want design stress strain curve for steel. So this is the, I can say, idealized stress strain curve for mild steel. So can some people will come and ask us, sir, I want design stress strain curve because I need to use that curve in design, right? So how I can use that one? Maybe I can say like, yes, definitely you can go and show it here in this way. So what is this? This is the actual stress strain curve, or I can say characteristic stress strain curve of mild steel. How you can work out the design stress strain curve of mild steel? Characteristic stress strain curve of mild steel divided by safety factor of steel, right? Can I write that one? So this is definitely I can write, this is design stress strain curve. What this design stress strain curve? It is characteristic stress strain curve divided by factor of safety. For characteristic strength is Fy. Fy divided by what is the factor of safety for steel? What is the factor of safety for steel in limit state of collapse? In limit state of collapse, the factor of safety for steel is 1.15. So I can write this stress here as, maybe I can directly write as Fy by 1.15. That 1.15 is the factor of safety for steel in limit state of collapse, which we can call it as, definitely this is equal to 0.87 Fy, right? So the design stress in, what is the design stress in steel? The design stress in steel at the time of failure, we can call it as 0.87 times of Fy. That is the note that I want to write. So can I write it here? Design stress for steel in limit state of collapse is equal to, after applying factor of safety, it is Fy by 1.15, which is 0.87 Fy. Some people will complain me like, sir, in steel structures na, you mentioned the factor of safety for structural steel as 1.1. See, there is a lot of difference between structural steel and reinforcing steel. This is reinforcing steel. For reinforcing steel, the factor of safety for reinforcing steel is 1.15 in limit state of flexure, whereas for factor of safety for structural steel in limit state of collapse is 1.1. There is a lot of difference between reinforcing steel and structural steel, bros. I hope you are able to understand. The reinforcing steel and structural steel different. Both are different, right? Both are different, so please understand that. So don't compare this factor of safeties for the factor of safeties in structural steel. That is structural steel, this is reinforcing steel. Okay, right. Okay, right. So some people will also ask me like, sir, you need to mention, sir, here that this is the, what is the strain in steel, which is nothing but epsilon st. You need to mention what is the strain, what is the strain that is developed in steel at the time of failure. I need to mention. But moreover, some people will also ask me like, sir, you had mentioned only the design stress strain curve for mild steel. This is the design stress strain curve for mild steel. Can you show me what is the stress? What is the design stress for HYSD steel? So can you show the actual stress strain curve for HYSD steel? From that one, can you show the design stress strain curve for HYSD steel also? Yes, why not? For what is difference between Fy and 0.87 Fy strength? So dear Shebin Sailuddin, okay, Fy is nothing but okay. Let me tell you, dear Shebin Sailuddin, Fy is nothing but characteristic strength of the steel. Characteristic strength of steel, which we call it as actual failure strength of steel. What is design strength, design stress of steel? Can you define what is design stress of steel? Design stress of steel. I hope you know from the fundamentals. Design stress is equal to actual failure strength of the material, characteristic strength of the steel divided by factor of safety. Characteristic strength of steel of material, that is steel, divided by a partial safety factor of steel of I should see partial safety factor of reinforcing steel. I hope you can understand. This is actual failure strength is Fy, but in design just for the safety purpose, just to account for uncertainties also, we are reducing the actual strength of the material. In such case, the strength that we had taken in design is nothing but design strength of the steel, just to account for uncertainties. Okay, so which we call it as Fy by 1.15, which we call it as 0.87 Fy. Is that okay, dear Shebin Sailuddin? At least have you understood now? Maybe you came at the middle of the lecture na, so that's the reason why you missed what is design strength of the material at the starting stage by 11 a.m. to 11:30 or maybe quarter to 12. I had taught this concept. Okay, so please go back to the lecture just after the lecture and you can work out this one. It's not at all a big problem, right? Can I rub the screen, dear Shebin Sailuddin, brother? Right? Nagarjuna or any other person who are on the online, right? Yes, I just want to rub the screen. So some people will say like, sir, you had shown only the design stress strain curve for milestone. First of all, you show me what is the. I just want to mention. I am interested to write this epsilon st value. What is stress in strain at the time of failure? In tension. I just want to write this one. To write that one, first of all, I just need to show what is the actual stress strain curve for HYSD bars. Can I show? This is how the actual stress strain curve for HYSD bars is possible. Maybe. Yes, from O to A it is straight line. This is for I can say stress strain. I can say actual stress strain curve for HYSD or I can say TMT bars. For any of the things I can say. So for HYSD bars I can say what is the grade I can say FE 415, FE 500. So FE 550 like that you can say. This is O. This is from O to A it is straight line. A is proportionality limit. So after this proportionality limit, non-linear elastic zone will come from A to B. It will go in a non-linear way. So from B. So after B also it will go. And there is no upper yield and lower yield is possible. So there is no upper yield and lower yield is possible in case of HYSD bars. It will keep on deforming with this curved fashion, and it will fail. And it will definitely fail somewhere here. Maybe this is C. So I just want to say like some people will ask us are how to find out yield stress for this HYSD bars because there is no upper yield and lower yield, right? In such case, how you can mention as the as I can say at a strain of 0.2 percentage, because at a strain of 0.2 percentage the material of concrete has got started yielded na. So I can say at a strain of 0.2 percentage, the strain is point not 2 at a strain of point not 2 or at a strain of 0.2 percentage, draw a line parallel to OA. If I draw a line parallel to OA, that line will cut this actual stress strain curve at this point B. So at that point B, whatever may be the stress we can call, whatever may be the stress, we call that stress as proof stress. That proof stress is nothing but it is nothing but at that point the material has got started yielding or some the material has got started yielding or some initial some I can say the material has got started yielding, and from that point from that stress onwards the material will go to plastic zone, right? That's what we can understand. So here I can say AB here, OA is linear elastic. OA is linear elastic zone, whereas AB is non-linear elastic zone. How you can mention about this zone BC? Zone BC is not at all a plastic zone. It is a strain hardening zone because it is increasing its stress here. Na? Maybe I can say BC can be called as strain hardening zone. The may strain hardening zone. Okay. So I just want to say like some people will cry at me like, sir, okay, this is okay, this is fine. What is the strain in steel at the time it has got yielded? By the time the what this is actual stress strain curve I can say. Now some people will come and say like, sir, can you draw this is the actual stress strain curve. Can you draw the design stress strain curve? Yes, why not? I can definitely draw the design stress strain curve. This is stress and this is a strain. So definitely I can show like, so from O to A, here also O to A, from A to B it is a curved, from B to C I am generally neglecting strain hardening zone. When I am neglecting strain hardening zone, instead of it as an inclined one, I can take that BC zone as a flat zone. This is the idealized stress strain curve. This is B. this is C, maybe I can say this is A, this is O. This is the idealized stress strain curve. This curve I will use. I won't take, I will neglect strain hardening zone. Instead of going it as an upper one, I am taking it as a straight line portion. Here this is the idealized stress strain curve, right? Idealized stress strain curve. We make use of proof strain. Yes, we will make use of proof strain. Yes, yes, dear Rabibi. And here I can say definitely here what is OA. Here OA in this idealized stress strain curve is linear elastic, no doubt. And I can say AB in this idealized stress strain curve is non-linear elastic, no doubt. And what is this BC in this idealized stress strain curve? Can you see in this BC in this idealized stress strain curve? This BC is just like that as a plastic zone, right? So BC is treated as a plastic zone here in this idealized stress strain curve. I am going to use this idealized stress strain curve. So, okay, after I use this one, this is the idealized stress strain curve. Some people will come and ask us, sir, I don't want idealized stress strain curve. I want design stress strain curve for steel. So, how you can get the design stress strain curve for HYSG steel? So, maybe I can say this is idealized or characteristic stress strain curve for HYSD steel. How you will get the design stress strain curve? Characteristic stress strain curve divided by factor of safety. So can I do that here? So this is characteristic stress strain curve. So can I do this divided by, maybe I can show this divided by here. Yes. Can I show here this is what is this one? This is design stress strain curve for HYSD bars, right? In this case, I hope you know at B what is the strain generally that B it is failing at B, and at B it is failing here at that time. What is the strain in steel? The strain in steel is called failure strain in steel at that time, right? But I want to consider that definitely if from here definitely here I need to draw a line of point not to, I need to draw a line from this to B. So this is the point. This stress is nothing but design stress. What is the design stress? Fi by 1.15. Corresponding to design stress, what is the strain? So this is strain, clearly I can write here as completely design strain. So strain in steel in tension zone at a time of failure. So what I can write this point is strain in tension steel at failure. So what is strain in tension steel at failure? Maybe I can say what is the strain in tension steel at a time of failure? Maybe I can say, if you please excuse me, if I draw a line, this line here I had drawn, which is parallel to OA. So what is the slope of this? The slope of this will be 1 and same. What is the slope of the stress strain curve within the elastic zone, within the proportionality limit? The slope of stress strain curve is nothing but Young's modulus of the material. So here it is Young's modulus of the material, so which is nothing but Young's modulus of steel. So how you can work out this strain? This is strain, I can say. So I can say definitely this epsilon st. So definitely this epsilon st, the strain in tension steel should not be less than this value, right? So I can definitely say strain in tension steel should not be less than this question mark value, should not be less than. How this question mark value I can get from here? So maybe let me show with the help of arrow mark. It is visible, right? I hope you are able to see this arrow mark here, right? From O to this point. Oh, 1 second. So from O to this point, from this question mark, from here to here, right? I just want to show what is thus that value, which is point not 2 plus again this extra value. So I can say clearly here that the strain maybe Yeah, but strain in steel it should not be less than 0.002 plus again this value. I hope if you had taken in this way, this is Young's modulus of steel. This opposite side is how much, man? Fi by Young's modulus Fi by 1 point Fi by 1.15 Fi by 1.15. And what is this question? What is this question mark? What is this horizontal distance? Young's modulus Es is equal tan theta, which is nothing but tan theta, which is nothing but Young's modulus of steel, which is Fi by 1.15 divided by this horizontal distance. So how I can write that horizontal distance? Fi by 1.15 into Es. So when the strain in steel, it should not be less than this value. Let us suppose when the strain, when the tensions, when the tensile strain in steel is less than this value, for example this value, then in such case the steel has not yielded more before failure, then it will show like the failure is sudden, which is not good. So strain in tension steel should not be less than this value. Always strain in tension steel at the time of failure should be more than this value, should be more than this value. If it is less than this value, then you can understand like definitely it won't give you definitely a ductile failure, right? Right. So I can say what I can write here clearly. I just want to rub the screen here. Maybe I can say rub the screen here. Strain in steel, strain in steel, epsilon st should not be less than 0.002 plus Fi by that gamma m. What is that factor of safety for steel material? Which is 1.15 into Young's modulus of steel. If you see generally, so that means you should understand the strain in steel should always be greater than 0.002 plus Fi by 1.15. Can I write it as 0.87 Fi by Es? Isn't it or not? Yes, I can write in that way. So that means to have proper indications of failure just before failure, to have proper ductility for the RCC structural member, the strain in steel should be more than this value. So I can say to show proper signs of failure, maybe I can say as a note I can write here clearly. So maybe a note. What is that note? To have proper indications of failure. So see here why we are trying to get this much minimum strain before failure. If this much, if the steel has got strained at least this minimum value, it will give more indications before failure, which will result in a ductile failure. So to have proper indications of failures with cracks in tension zone, the strain in steel at failure should be more than 0.002 plus 0.87 Fi by Es. Like that we should try to design, right? If the strain in steel at the time of failure is less than 0.002, in such case the failure is a brittle failure, right? I just want to write that note. This is maybe note 1, and I can say the note 2. If strain in steel is less than 0.002, then I can say there will be a sudden failure in concrete. There will be a sudden failure in concrete. There will be sudden failure in concrete in compression zone without any indications of failures. If the structure has got failed suddenly, that is there may be a huge loss of life will happen for the residents who are inside that structure, who are staying inside the structure. So always in addition to strength, the ductility is very much required. So like that I need to design. So please understand that. So that is the design of ductility is very much encouraged. If we don't, if strength is good, but if the straining capability of that steel is not that much, that will result in brittle failures, which is not at all good. Okay, right. So as for today's thing, I think the time has already got over. So in tomorrow's think in tomorrow's session we will work out the stress block parameters, and we will work out the remaining part in the next coming session of tomorrow, right? I just tried to cover so much things, but unfortunately because of so much of reasons I just covered only a little. So please excuse me about that. But anyway I will take but anyway by the end of December I can complete most of the important topics of structural part. So definitely that will improve your score. And moreover we will work out lot of problems also. But here in this concept I cannot jump directly to the problems. If I directly jump to the problems, most of the questions were asked like I need to derive our own stress block from from the stress block. I need to derive own compression force and tension force values. From that one I need to work out. For that one all these basics are required. Without these basics we cannot directly jump down to the problems, right? So 1 second bros. So limit state of flexure will take 5 days bros. Limit state of flexure itself will take 5 days. So before the end of the session, I just want to convey you. If you're a serious aspirant of GATE or ESE, then definitely I can recommend you to take a paid course. If you had taken a paid course, all the topics, all the 100% subject, we will teach you in detail. If it is a free course, at max 30% of the syllabus we will cover. But if it is a paid course, definitely all the entire syllabus will be taught you in detail, so that even the below average student can cope up with our lecture. That is one thing. And if coming to the price, if it is 12 months course, the cost is 27,225 after 10% discount. If it is an 18 months course, after 10% discount, the cost is 34,650. If it is a 10 per if it is a 24 months course, after 10% discount, the cost is 39,600 in an academy learning in an academy plus. So you can purchase this one by downloading an academy lab. In an academy learning lab, go to an academy plus, and you can purchase this subscription. By the time you are using the by the time you are paying, use this code BD10 to get definitely 10% discount pros. And I just wanted to say, like, we had already started 3 new different batches in this Let's Crack Gate and ESC Civil YouTube channel. Take use of these batches. This is our for free of cost. We will do most of the syllabus we will be completed in the formats of questions. Okay, right. And I just want to convey, get learned from the India's topmost faculty. Here as a group we are teaching you here. And every day my class is happening in this Let's Crack Gate ESC and Civil channel. My class is happening every day by 11 a.m. So from 11 a.m. to 1 p.m. 1 p.m. My class is happening. You can take use of my classes and other classes also, right? So before I end up the session, I can encourage you, I can recommend you, like, definitely you can subscribe to this Let's Crack Great and ESC Civil YouTube channel. When you had subscribed to this channel, you will not miss even a single class, because notifications will come down to you. When notifications will come down to you, definitely will not miss a single class. So don't forget to press the bell icon after you had got the after you subscribe to this YouTube channel. And moreover, I already started a Telegram group of mine, and the name of that Telegram group is Unacademy underscore Civil Engineer Tilak. If you want to come down to that channel, you press the link which is given below, and the link is https slash t.me slash unacademy underscore civil underscore engineer underscore Tilak. You can press over that link. It will redirect to my channel. When you come down to my channel, definitely you, whatever maybe the doubts you have, you can ask me the doubts, and I can resolve all your doubts there for free of cost. Okay, this is the thing. So and I can recommend you, and I am expecting you one more thing. So to do more free content for you, So please share, please like our videos, please share these videos to your friends, because they will also get benefited. At least these videos are for free of cost now, at least they will also get benefited. So thank you very much. So please share these videos, like these videos, and subscribe to our channel. Thank you very much. End of the session.